All right. Welcome to this webinar. I'm just having a little bit of fun trying to organize my screens here. I think I'm sorted. Okay. So my name's Liz Rice. I am Chief Open Source Officer here at Isovalent. And today we're going to be having a discussion about cloud networking. This was kind of triggered, the idea for this webinar was really triggered because GigaOm created a radar report about cloud networking in which Isovalent was featured and described as a leader. So that gave us the idea to have a conversation about cloud native and cloud networking and cloud native and how those two things relate. And I'm delighted to welcome our guest for today, Howard Holton, who is the CTO at GigaOm. So welcome, Howard.
Oh, thanks for having me. It's good to be here.
So before we dive into some questions and discussions, just a couple of items of housekeeping. So we really want this to be interactive and we want to cover topics that you, the audience, want to hear about. So if you do have questions, there is a Q&A tab that hopefully you can find. And if you can use that, that would be great. We're also very pleased if you, write things into the chat. I can already see a couple of people, Ahmed and Anu, who have said hello. So thanks for introducing yourselves and saying hello. As we go, let's try and have as many questions as we can cope with. The other thing I should mention is that the session is being recorded. So after the session, you will get a link to the recording, and that email should include links to everything that we mention, including, let me just quickly click through to bring up a little bit more detail about the GigaOm radar report for cloud networking. Howard, your colleague, Andrew Green, authored this. So I'm not expecting you to have memorized every word of it, don't worry, but I have found a few interesting quotes from there that might form some interesting points for discussion. And if you're watching and you want to download that, you'll find the link right at the top of Isovalent's website. And a couple of slides there picturing us, so you know who you're talking to. All right. So I think without further ado, I'm going to stop sharing those slides so that there we go. I can see us both in full glory. Oh, I hear Andrew Green is listening in. That's awesome. So if we do have any questions about the report, we'll be able to ask you for your opinion and your points and knowledge.
Let's talk about pressure.
So, Howard, let's start by talking about cloud networking and cloud native networking. What's the difference, in your opinion?
I think that's a complex question. I think it's a complex question because I don't think we do a good job of defining terms in this industry.
Naming is hard. One of the hard problems of engineering.
Naming is hard, and then it's kind of interesting, right? Oftentimes, open source projects are the tip of the spear on kind of naming conventions and naming the purposes of a term, I guess would be a good way to put it. And then commercial marketing teams get a hold of it, and all of a sudden it starts to drift, right? FinOps is a good example, where it suddenly has become anything that analyzes the financials in an IT department is now getting the label FinOps, which is not at all what FinOps is about. So when I think of cloud networking versus cloud native networking, right? It brings up two very, very, very different things in my mind. The first is the complexity. Cloud networking is the complexity of managing a hyperscaler environment more than anything else for me, right? And for those that think that is simple, I encourage you to take another look at your cloud configuration, because it's likely that you have some security concerns that are going to be exposed by that. Cloud networking really introduced or highlighted or made clear the security concerns of a network in a massively scaled shared environment. And so the amount of effort we needed to put into cloud networking far exceeded the amount of effort we tended to put into cloud networking. And I would say even the hyperscalers early on didn't take a really good look at kind of the tooling around the networking that they made available and the networks, the kind of tools that are available, the visibility that's available, and the priority that we set. And that started to become clear in the last couple of years. Cloud native networking is really part of your cloud native tool set, which is different than simply cloud, right? Cloud is this huge bucket of things, infrastructure as a service, as an example, platform as a service, right? Those things that I consume. Cloud native, on the other hand, when we talk about cloud native, we're talking about containers, serverless, Kubernetes, Docker, that kind of bucket of things. And we tend to, at least, dear God, I hope, we tend to configure, manage, and run those things significantly different than we do anything else traditional, right? Like if you're not running DevOps, if you're not running CI/CD, if you're not pipelining, if you're not running infrastructure as code within cloud native, I would argue that you're not actually running cloud native.
Right? I think that's very true. Yeah, I mean, automation is a key, fundamental of
mandatory
cloud native, for sure.
Yeah. And I think that's actually part of the problem with the adoption of cloud native when we look at it, right? When we look at the adoption of containers, I think everyone was able to adopt containers easily. Like I run them at home. To be clear, I'm a CTO, right? I'm a pointy-headed boss. Right. So I run a lab at home, and I run containers at home, and I've got my K8 set up, and I'm playing with K3s, and I run Ansible. But I'm a novice. Like I don't get paid to do this stuff. I run it because it's fun, and I'm still a techno geek. But the reality is we all did that. And even when it came to doing software development projects, we all did that. And then we need to scale this. We put it in production. And what we found was, holy crap, this stuff's hard to scale. Part of the reason was we didn't look at the networking component in the same way that we looked at the CPU and memory and storage component. We assumed the network would work more than we did.
Yes. And it's very interesting that Kubernetes treats networking as a plug-in thing that you add on. It's not even part of the core offering. So, which is where projects like Cilium come in as an option that you can use to implement your networking, but it isn't provided for you as a default.
It isn't mandatory, right? Because we've always thought that networking was the wires. I'm simplifying on purpose. And the wires would just work. And your networking team would make sure the connectivity existed. But that's not how you scale, right? That's not how you have global namespaces and make those global namespaces work, right? That's not how all this stuff remains seamless. This stuff remains seamless because you spend as much time focusing on how the network works efficiently as you do wringing every last megahertz out of your processor and every last kilobyte out of the available memory. Right. This stuff works. Like the whole purpose of Docker is to be extremely efficient, and to ignore networking was silly. Right. In the same way, it's also part of the evolution, right? We ignored storage when this whole thing started. Right.
Yes.
It was all about stateless containers when this whole thing started. Right. And then we went, ooh, that's probably a mistake. I think we need to go back and fix that. Holy crap, this is terrible. And then all of the challenge around making stateful containers, right? There was 18-ish months of heavy work where anybody that played with stateless containers found out the limitations of the order of operations became really critically important, and the tools didn't consider it, right? So you'd bring up containers where the storage wasn't available. And then, of course, the container would fail, and it's part of your infrastructure rather than the whole thing. So some clients would work and some clients wouldn't work, depending on which container they were hitting for the particular resource. It was awful. And now we've come to this kind of the same realization with cloud networking. And to be clear, cloud networking is no longer about the wires, right? It's no longer about connectivity. Cloud networking is really about security.
Okay, all right. I'm going to also throw in the word observability as well, because I think, how do you know whether your security tool is working if you don't have observability over what's happening? And also, how do you ensure that things are connected if you don't have observability over how things
I don't like creating terms, but I think in the next year we're going to see, so DevOps became DevSecOps. And I really want to be clear with that term. Like if you're not running DevSecOps, you actually are. Like if you're just running DevOps, sec just has a null value.
Okay.
right? Like we've all been doing it. It's just had a null value. I think we're going to get to DevSecOps, right? Security observation and operations. The truth is, security without observation is not security. It's just it's a black box of things that occur, right? So I think if it doesn't go without saying, I think it should go without saying that anytime security is involved, observation should be a key part of it. And generally, when we talk about network observability, what we're getting out of it is security. The performance statistics are secondary to the security value. The anomaly detection, what we're really looking for, first and foremost, should always be the security anomalies. Secondarily, the failure anomalies.
Yeah, you absolutely need good observability to be able to solve both problems. And I guess sometimes when you have a failure in connectivity, you don't know whether that's because of just a failure in connectivity or because of a security event. So you're going to need the observability to even help you figure out which of those categories
really well with your container observability anyhow, right? To do modern applications, to do cloud native applications at scale requires observability in every single layer, right? So my compute, my storage, my configurations, my everything, my networking and my security all have to be observable. Otherwise, I'm not going to be able to scale properly. Right? I'm constantly going to be limited.
And I think this is one of the reasons why eBPF is so powerful, a platform for building this kind of observability, because by having eBPF instrumenting the kernel, we're able to get insight into all these different aspects, whether that's networking, storage, executables, permissions, privileges. All those things can be observed from the kernel layer. And I think that's, a fundamental building block that we used, in creating Cilium, was knowing that the kernel is a great place to observe everything that's going on across a machine.
The kernel's a fantastic place to observe everything that's going on with the machine. What's interesting about the last 10 years in this industry, and you could argue the last 20, but it's really the last 10. Let's say this industry is 40 years old, right? Technology is far older than that, right? The mainframes go back further than that, but it's really client server, right? The PC revolution, they kind of changed, and it's really about 40 years old. Please don't tell me that it's older than that for those on the because it means I'm much older than I am in my own head, and this is already hard enough for me.
We can start talking about those old terminals that used to connect to servers and mainframes.
Sorry, I need a minute. Getting old. So when we look back, right, everything that was designed and created was designed and created with CPU constraints in mind, right? The way RAID operates, right, fundamental building block, was designed because compute was incredibly expensive, and so you needed dedicated infrastructure to just manage how stuff was sorted on disk. Right? DNS, there's no security in DNS, none. DNS was created to replace host.txt files. It's literally what it was created for. It was designed to be distributed because there was no way for any single system to contain all the DNS records that existed in 1987. Right? Like the first step in security to the internet, which is HTTPS, really wasn't ratified until 2000.
Yeah. Okay. Yeah.
So today,
we've come a long way since then,
right?
And now we want all of our connections to be.
And now we want everything secured.
Yeah.
Now we have multiple layers of security when just 23 years ago we ratified one. In reality, right? So one of the things that I think is important to think about is the cost has changed. We still look at the cost of CPU as though it's a real thing. I'll be honest, it's not a real thing. Right? When I look at all of my costs, the cost of people, by far the most important. My organizational cost, the cost of change within my org, by far the most important. Followed by downtime, second most important. Right? Like if we're running at 4 nines, an hour of downtime will likely cost you roughly the same as three humans, and the people are much harder to find than the uptime. I can find uptime in a million ways. Finding people right now is very, very hard. Although, you know, you want to hire from Silicon Valley, I hear it's become a little bit easier.
There are some good people available, I hear. Yeah.
I hear. By the way, if any of you are listening, please hit me up on LinkedIn. I'm happy to help you. I'm happy to help socialize you and help you find something else. I've got a huge network, so happy to leverage that. So one of the things that I think everyone stumbles on, and I do too, when I hear we inject in the kernel, we watch from the kernel, we do these things in the kernel, is, ooh, what's the cost of CPU? That's the cheapest thing I have in my entire IT infrastructure. The cheapest thing I have is add more CPU. It's the easiest thing to do. Don't worry about it, right? Start thinking about not how does this stuff affect the cost of my infrastructure as a service or my cloud native cloud provider costs, but really think about how does this stuff affect my learning curve? How does this stuff affect my deployment models? How does this stuff affect my reliability? How hard is it to find someone that understands this technology? And how hard is it to learn it and onboard yourself, right? How hard is it to go from DevOps to DevSecOps to DevSecOps? God, I hate that already. Right, but how hard is it going to be to make each of these kind of evolutionary transitions that really help make your organization better, with the goal to impact the people in a positive way and your uptime in a positive way, ultimately leading to ideal digital experiences.
You mentioned there about sort of ramping up, and I think maybe it's a good time to bring in the first question from the audience, which Anu says, it's a beginner's question. As a DevOps engineer, how can one acquire fundamentals of networking? And I think more importantly, how much depth should one have in networking knowledge if you're a DevOps engineer compared to a specialized network engineer?
Is it okay if I give my favorite answer that's totally not corporate?
Absolutely.
Techno Tim, YouTube channel. He's one of my 3 favorite YouTube channels. Techno Tim has a complete, I think it's a complete CCNA course, which is Cisco's Computer Network Associate course. It will teach you everything you need to know about networking, and he has a whole DevOps course where he integrates the two. They're free. I'm not recommending anything that you pay for. They are completely free on YouTube. He's incredibly bright. He's incredibly fast. He's the first place I go to when I'm wanting to find something. I really can't recommend him enough. He's a big coffee drinker, so if you're into coffee, he's got some great recommendations. There's another guy that I can look up and give you guys for show notes if you want, that I also recommend. But as to kind of the depth of knowledge, I firmly believe every DevOps engineer could be well served by the equivalent knowledge of the CCNA or like Network Plus. They both kind of teach the same thing. I think it's important that you understand how routing and switching works, what kind of happens at layer 3, layer 4. Layer 3 and layer 4 are effectively the IP routing layer and the kind of port protocol layer. Those are probably the 2 most important, and I think it's really worth having that knowledge. Feel free to up afterwards.
That leads to a really interesting point that I found in the report. So, and it was talking about how DevOps team really want to work at layer 7, being the application layer. So really talking about network offerings from different vendors, providing a layer of abstraction where I will quote from the report: at this higher level of abstraction, service-to-service connectivity and content-aware traffic processing are 2 of the most important use cases that cloud networking solutions need to address. Rather than having the networking teams handle construct at layers 3 and 4, I'm going to paraphrase now, those can be automatically provisioned so that the DevOps team can concentrate on layer 7, content-aware and service-to-service connectivity.
I completely agree. But that's actually the reason why it's more important to understand those fundamentals, I think, right? So that when something goes wrong, right? Automatic abstraction layers are fantastic every time they work, right? But when they don't, being able to go to the networking team and have a conversation in the language that they understand, right? it avoids the finger pointing, right?
Yeah.
Cuts down the finger pointing and get you to get your mean time to resolution, which ultimately is what we're searching for, down as fast as possible. And even if you have to go back to your cloud networking vendor and have a conversation, you can still have a conversation about root cause without having to actively configure it and actively think about it. None of us want to actively configure layer 3 or 4. Seriously, I want that to be as automated as possible, but being able to understand it means I can, in fact, pick it apart. I can do better root cause analysis, and I really understand what's going on under the covers. And so I also understand the impact of decisions that are made by these systems. And when I start to see error messages, I know how to work through them much faster. And you don't have to call in another team to do that.
Yeah, I think a great example of this is the kind of error messages that you get. It's an application layer when your networking connection fails, perhaps because you don't have the right certificates or the port isn't open at the other end. Just having that understanding of what those error messages mean can, stop things turning into just a sort of wild goose chase. And you can be very specific about, I know what kind of problem this is, for even the sort of basic kind of problems that you will run into when your application can't talk to each other.
How many times have you been working on a project, you've received an error, you've gone through it, and you've determined the error belongs to the infrastructure team or the networking team or the security team. It's outside of your control, and you forward the error, you open a ticket and you forward the error message on, and the team comes back and goes, I have no idea what that error message means. And you go, I don't know, it's an error message from a library. I don't necessarily know it either, but it's your problem. Right. And so there's all of this back and forth. And let's say everyone is genuinely trying to solve the problem, and simply there's no common language there. This also will help give you that common language and allow you to go, what the error message is saying is that we're getting blocked on port 579, right? Or TLS is being blocked, or whatever it happens to be, right? And then they can go, oh, okay, cool. I know how to deal with that. Hey, can you change to this port? We don't allow that port, or whatever has to happen. Hey, we just switched to DNSSEC, and that's actually now an encrypted DOS packet, and you've got it configured for DOT, right? Being able to that's DNS over HTTPS, or sorry, DNS over HTTP or DNS over TLS. By the way, don't use DNS over TLS.
Is there a story there that you want to tell?
Yeah. If your company is considering DNS security, which you absolutely should, it's like a 3-click turn on. TLS tends to get blocked on all your mobile devices, so DNS over TLS will work fine in the office, but when someone takes that laptop and goes home, your home internet provider is likely to block the TLS port for DNS, versus they can't really block the port for HTTPS.
Makes sense. Yeah. Totally makes sense. So I guess another thing, we talked a little bit about the difference between cloud networking and cloud native networking. Now let's turn to what happens if you're operating in the public cloud. At what point do you start thinking about, well, should I just use that public cloud's networking capabilities, or should I be looking for more? What kind of criteria would you be looking for?
That's an excellent question. So for those who are listening, I don't ask for the questions beforehand. Sometimes I get them, sometimes I don't. I don't always read them. This is a really good question. And really, I think it's a multi-layered answer, kind of like previous answers. The first is, what are your plans going forward? Are you going to be in a single hypervisor? Does that hypervisor hyperscaler, does that hyperscaler handle all of your needs? It's absolutely fine if the answer is yes, right? If yes, we're a Microsoft shop, we're going to be in Azure. We're a Google shop, we're going to be in GCP. AWS has regions everywhere that we need them, and so there's no locality issues. I will kind of warn you that that's not likely to be true moving forward, right? Today, there's a ton of money in cloud, but competition is increasing, especially for things like edge computing, right? And a lot of cloud native applications, we need to leverage the power of the edge. And when we're talking about the edge, what we really want is we want a sub 20 milliseconds response time. In order to get to a sub 20 millisecond response time, the maximum distance from the endpoint to the compute 1,000 miles total.
Wow.
And that assumes the compute is free, as in there's no additional latency from that, right? We want 20 milliseconds for the customer to feel that this is real time. And so if we look at various vendors, right, you'll have a telco that has 1,000 edge locations and AWS that has 25. So even if I say AWS is where I need to be, right, I may then have to go, oh, well, I need this application to be near this customer. And in order to do that, I have to use a local or a telco edge provider. They have the locations. And so if I were to use the cloud native networking components that are provided by my hyperscaler, that's then going to limit me because those will not similarly be supported at my edge provider, right? And we talked about abstraction layers. The goal of abstraction layers is to give you kind of a common language to write to without having to know the underlying language. Well, the same is true here. If I choose a good, a quality, a trustworthy cloud native networking layer that is independent, I can then move from Amazon to Azure to GCP, back and forth, even local in some cases, as well as out into these edge providers. Whereas the same is not necessarily true for what's used by the cloud providers as their kind of default option. They can, at the same time, they can be a good stepping stone, right? That doesn't mean you stop everything. That doesn't mean you retrofit everything, right? Good architectural planning means you consider it. You consider where you are. You consider the things that you can, in fact, control, that you can change, that you can take into consideration now, and you plan for the future. So, retrofitting is not a nightmare, as well, It's not fun. It's not fun, but it's not a nightmare.
I think we see, increasingly in the early days of Kubernetes, everybody was talking about, a Kubernetes cluster. And then I remember when, multi-cluster, is that really a thing? Well, it certainly is really a thing. And now we're seeing increased conversations with users who not only have that set of Kubernetes clusters, but they're also trying to communicate with external workloads and existing, maybe on-prem services that maybe haven't been migrated to on cloud. So having a networking solution, Cilium being a great example, that can bridge all those different, different types of location where you might be running those workloads, could be very important to you if that's the situation you find yourself in.
Yeah, I agree. And I think it's a piece of the architecture that you need to think about, right? When we look at cloud native workloads versus traditional workloads, cloud native is 10 to 15%, right? Is what we're seeing today. Ultimately, in order to convert my applications, a large percentage of those are provided by third parties. I don't control the code for this. Right? Even the ones that I do control the code, the ones that are the most recent are the ones that I know the best, and thus are the ones that are the easiest to modernize, right? Convert to cloud native. Something that I wrote 30 years ago and have continued to limp along is likely to carry a tremendous amount of technical debt, and likely not to be an easy target for modernization. Maybe a very, very good target, but may not be an easy target for modernization, in which case I'm going to have years and maybe decades of having a mix of cloud native and siloed applications, traditional monolithic applications. And so I need to consider an architecture that supports the kind of gamut of what I need to work with. And I don't think that there's going to be a day while any of us are still in the workforce where there will not be legacy applications that I have to at least exchange data with. So I probably consider that in my strategy.
What about the idea of cloud lock-in? That's a term that comes up every now and again, but is it a real thing?
Cloud lock-in is a real thing, as is repatriation, right? I don't think we can talk about one and ignore the other. And cloud lock-in happens simply because of what we talked about before, right? You use the tools provided to you by the cloud vendors, and then you find something changes, you'd like to look at another cloud, and there is no easy translation layer from the proprietary tools of one cloud hyperscaler to another cloud hyperscaler. and the amount of effort outweighs the ROI that you would get from switching to another cloud. It's an absolute real thing. And so I do think it's worth having the conversation, right? There is generally an expense involved, but it is worth the conversation. Again, software is cheaper than people. Right. So really think about, if we're going to spend the time to teach our people to create standards, to create, development practices, should those development practices be on things that are independent and thus carry across clouds, or should those things be focused on the cloud provider that we've selected as our enterprise cloud provider?
And I guess that also ties into the sort of conversation earlier about skills, and whether you have people available who have skills in that particular cloud provider, or in an abstraction layer across different, that works in different clouds. And you probably need both, because you're unlikely to be able to run one without also being able to having some knowledge of how to run in that cloud.
That's very true. The additive layers of things we need to learn and understand are far from free. And for leaders, it does add complexity, without a doubt, right? If you just think about the courses necessary, I can get up and running with a course on how to do X in whoever my provider is, right? How to build a modern application and integrate your DevOps stack into GCP, as an example, right? But to pick and choose the pieces of the stack, it becomes more complex, right? And so it is more training, it is more people time that I need to invest in. And what I would really encourage is look and see, like when you're picking pieces of your stack, take a look out on the market and see what are the skills people are asking for, and what are the skills that people have. Right? Take a look at resumes, take a look at LinkedIn, right? What you're going to find is there's some commonalities across the stack, right? Like we all talked when Microsoft showed up with Azure. In the executive seat, the conversation was, well, should we use Azure? Maybe. But the fact is, I can hire 5 or 10 AWS developers for every Azure developer.
Wow.
Right? The simply people, AWS had been around longer, and the workforce knew that technology better. Right. I will posit that if someone has experience in a cloud native networking tool, they probably know it 10 times better and know cloud native networking 10 times better than someone that says they know AWS networking. Mostly because you simply inherit AWS networking, whereas you have to actively learn any other tool. Right. And so I'd really, I'd really consider I'd consider that as kind of part of the strategy and part of the conversation and part of your, your hiring practices.
That's a really interesting point. I will mention, since we just talked about sort of qualifications, the Linux Foundation just recently launched, in fact, I think it went live today, a course on Cilium, sort of introduction to Cilium. So if you go to the, I think it's training.linuxfoundation.org, something like that, you will find and search for Cilium, you will find this new course that will bring you up to speed, or your team up to speed on Cilium. Okay, so maybe we should go back a little bit to the idea of security being an inherent part of networking. What does the term zero trust mean to you?
Okay, so there's 39 participants. I think 37 of them just rolled their eyes. And that's okay. Because like I started saying early on, we do a terrible job of defining terms, and then they get grabbed by marketing teams, and then we get exhausted by them. So I'm a big fan of zero trust. Zero trust is a philosophy that says my sphere of trust is effectively zero. My sphere of trust used to be the boundary of my network. It's really what it used to be. And that's we used to build forts, right? And the same way we built pillow and blanket forts when we were kids, we built forts in our network. I really focused my protection on those things that were outside of my corporate network. I built these huge walls and moats around it. And then I kind of said everything inside I trust. Well, that's a bit of a problem. And it's especially a problem as attackers went from maybe impersonating users to now impersonating applications to now, creating a beachhead and then pivoting inside a network, right? It's especially a problem when we went to a fully distributed workforce, right? And therefore, I no longer have a network that I can moat. I go to the cloud. I don't own those networks, and therefore I can't moat them. I can't fortify the edges in the same way, nor should I consider that once the edges are fortified, my core is secure, right? When we look at supply chain attacks effectively punch holes where holes didn't previously exist, and thus open up considerations that I didn't have before, right? And so what Zero Trust says is, because of all of the different attack vectors that are available and all of the different penetrations that we're seeing and all of the different activity that's been witnessed, you need to think about your network as having nothing that is trustable. And thus, we verify every single connection, every single request, every single time. And that's all it is. And the goal is to use Zero Trust to reduce the blast radius. So when I'm architecting security, what I need to think through is, if this thing is compromised, not could it be, but if it is compromised, we're just going to skip past, right? None of the security worked. What is the damage that could occur from this out to the rest of my world? So how do I reduce my blast radius? That's step one. And again, right, that's kind of one of the purposes of security baked within cloud networking tools, is that reduction in blast radius, right? Really thinking through, years ago, we would have called it microsegmentation, would have been a way to reduce blast radius, right? As we're thinking through this, how do I reduce the blast radius? Well, the best kind of early step is I make it so that the network isn't an open field of communication, right? That's one great way, so that the system can only communicate with the things it must communicate with and nothing more, right? That's very, very, very hard to do, and mostly why microsegmentation failed early on, because we built thousands or tens of thousands of rules that no one could keep straight, right? That's where orchestration and observation really start to play in, right? Because now we have tools that can orchestrate this across large swaths of our infrastructure. And we have the observation to confirm the results, support the results, implement, and then observe and make sure nothing changed afterwards. Without the observability, I think it becomes much, much harder to implement a reduction in blast radius. And that's kind of the fundamental of Zero Trust. It is a philosophy. Are there products that are Zero Trusty? Certainly, but they have a specific defined category. ZTNA, Zero Trust Network Access. It's fine. It uses the philosophy, the fundamentals of Zero Trust to provide network access. I can buy that. Someone that says our product does Zero Trust needs to just go away. Zero Trust is enormous and literally touches every single thing within your infrastructure.
Yeah.
Right? User access, right? Networking, literally everything, ACLs, everything, right? And there's no product that does all of that, right? But Zero Trust within a narrow function, Zero Trust cloud networking, I could buy that, right?
Right. Because in order to establish whether a given connection is valid, you need to have the identity parts, you need to have the authorization parts, the potentially that kind of let's call it firewalling or network policy to sort of allow or deny traffic between these different components. All of those things are kind of
and I need to have policy
required to work together. Yeah,
I need to have policy management.
Yeah.
Zero Trust also means my level of validation and the level of trust verification that I go through changes based on scenarios, right? I may have one level of authentication verification that you go through when you're coming from your home network, and I've seen your home network for the last 90 days and 90 logins. But all of a sudden you're in China, I may have a whole different level of verification that you go through. Right? And that requires, again, kind of kind of logging and policy applicability that you just kind of have to have. You need to be able to integrate those things and talk to those things and really lean into what does this mean. And I suggest everyone, when someone says there's zero trust, ask questions, dig in. What do they mean by zero trust? Is it just marketecture, or do they actually understand zero trust? And are they willing to dig in, and do they support the fundamentals of zero trust, or are they just saying there's zero trust so that so they get some Google hits?
Yeah. I think that term microsegmentation, the idea of microservices is to give us these standalone applications or componentry of applications that do basically one thing. Each service does one thing, and I think that does allow us to start reasoning about what the policy for that service should be in a way that we couldn't when we think about a holistic monolithic application. What's supposed to happen when it fails, how many different services is it, but I always use the example of a retail online store, and if you have a product search microservice, totally makes sense that it's going to have to access the product database, but it should never be talking to a payment system, and that's very easy to reason about.
Yes. And some of this was much easier when we developed monolithic applications, right? Because that search component, right, library that sat in that monolithic application couldn't talk to anything else because it wasn't really aware of anything else. But now everything has the ability to communicate with everything else. It's a network service, and therefore you've kind of opened the door for network services, right, to anything else on the network. And so you need to be hyper aware of kind of what you've enabled, right? And therefore take the extra step and make it part of your architecture, make it part of the design, right? Talk about it early and integrate it early, and that'll lower the amount of felt friction while achieving the same goal, right? The goal of security is friction.
And do you think that should be the responsibility of the development team who are building that service, or a platform team, a network team? Who should be involved in thinking about those policies?
I think it depends greatly on your organization, on the maturity of security within the organization, the size of the organization. I think it's everyone's responsibility. I don't think it's just one kind of group's responsibility. There are plenty of organizations today that produce a lot of code that don't actually have a platform team, or where the networking team and the software development team have never spoken once, couldn't call out each other's names, right? They open anonymous tickets, but otherwise couldn't quote each other's names, right? And so I think you really need to look at who is your organization, how is your organization defined, and if all of those things are disconnected today, then it's probably time to start talking about something like a central architecture team that like an enterprise architecture team, which isn't really the goal of enterprise architecture, but it's fine to think about it that way. To start thinking about some sort of governing body that looks holistically at the organization and says, hey, these are the things that we need to consider. These are the challenges that we have that we need to overcome, and then figure out where it logically needs to be located. I wish there was an easy answer for that. I wish I could just kind of point to one place and say that's where it needs to go. But I'm not sure that works for even most organizations, right?
For sure. I'm just going to point out to the audience that we've got a little bit let's say a little bit over 10 minutes left. So if you do have a question, or there's a question bubbling up in your mind, now would be a really good time to type that in. And while you are hopefully constructing those questions for us, we've just talked a little bit about services and kind of microservice architectures, which leads on to the term service mesh. What are your thoughts on service mesh?
I think service mesh is a clunky term and a clunky concept that means a lot of different things to a lot of different people. I don't have a clear definition for you, but I tend to think about service mesh as the kind of background shadow that keeps all this stuff working. And I have seen a lot of different I have seen a lot of different implementations of service mesh and some from surprising places, right? But ultimately, it is in fact the layer that allows all of these microservices to communicate in the ways that they need to commonly communicate. And if you've not thought about your service mesh, if you've not thought about what you're going to use and who you're going to use and why you would choose to do that, you're making your application modernization infinitely more complex, right? The commonalities contained within cloud native applications are huge, and leveraging a service mesh is important to take advantage of those commonalities. And a failure to scale might come back to a failure to properly build your service mesh. It's also important to note that it is in fact the chatter that occurs, right? It's the best way to think about it is it's cloud native overhead is service mesh. A lot of overhead in being cloud native. And so I'm certain, many of the people on the call read the article about AWS and how Amazon Prime Video pulled back their containerized video processing and delivery service and went back to a monolith, right? And for those that saw that and read something bigger in that, what they said was this thing kind of did one thing. It did one thing that was built really well to consume resources in a monolithic fashion, and the cost of the service mesh was incredibly high for this application. This wasn't we're getting away from containers, which is how a lot of people reported it. It was when we built this, we built it because, well, we could. It was fast and it was easy to do this way. It allowed us to do it at great scale. And as it continued to evolve, what we realized was there was nothing wrong with the monolith that we started with for this purpose, for this application. Right?
Yes, I think that's exactly it. It's about the specifics of a particular application and whether you should break it up, and if you do, how you break it up and how much those pieces then need to communicate with each other.
Agreed. And in their case, right, the background chatter, the service mesh communication layer was heavier than the video transformation layer and the video delivery. And so all of a sudden they're like, well, this doesn't really make any sense. And they went, well, it makes more sense as a monolith. And that's one good way to kind of stay on top and measure how much chatter, right, is going through your service mesh versus how much chatter is actually going through the application that makes you money. Service mesh will never make you money. Right? There's no ROI on a service mesh.
Sure. Yes, it should just be part of the infrastructure. Yeah, it's not business application logic. Yeah. We have got quite a few questions coming in. So I think one of them actually, well, it's more of a comment, and I'll take this one first just because it relates to service mesh. And it's Serge saying that it's in a way layer 7 layer for DC data center, I guess, with observability and traffic shaping, in his opinion. Now, I'm going to just caveat that we find that when we talk to people about what they're looking for from a service mesh, the answer varies so much. Like for some people, it could be, yes, we're looking for observability and traffic shaping. But for others, it could be, we're looking for that mutually authenticated encryption connection between services. It could be about, we want ingress and we want to be able to then direct, essentially we want an ingress gateway that can parse the URL and figure out what service is going to respond to that. So it could be about canary rollouts. There's so many different things that it means to different.
Yeah, and that's why it's interesting to me to see all the companies producing service meshes today.
Yeah,
right? Nginx has a service mesh offering, right?
Yeah.
And for me, Nginx was always a reverse proxy. It's always what I used it for. And I went, they have a service, like when did that happen? When did that show up? And they're like, oh, it's been here forever. Forever in cloud native tooling timelines, which is like 3 weeks. And so what's interesting about that though is it makes perfectly logical sense when you think about it because of exactly what you said, right?
Yeah.
Because it is that kind of background communication layer that happens. There are so many things that can go into service mesh. I stumbled over it when I first heard the term. I'm like, what are you trying to say? And then I said what I said, and they went, yes, but, And the but is it does really, really, really specific things, and you don't need to use all of them, but there are absolutely some. And you need to consider, what your service mesh provider is going to be again, right? What are we looking to do today, and what are we looking to do tomorrow? And is that common communication layer a good place to standardize our APIs, as an example? Is it a good way to standardize our ingress and egress?
Mm.
Right.
Another question from Andy. One big headache with cloud networking is the egress and transfer fees from some providers. Are there any tools or methods to make this more visible and easier to plan around?
So observability. None of this works without observability. And the fact is, if you're multi-cloud, service mesh will in fact increase the quantity of egress that occurs. And what you really need to think about is, does the value of multi-cloud outweigh the cost of that service mesh communication? If the answer is we don't know, you probably don't need to be multi-cloud. Right? Multi-cloud should be a very, very, very specific financial decision, not a technology decision. We need to do this because we can't reach our customers based on the locality of AWS. We've had too many outages. There is some service that's available on another hyperscaler that's not available on this hyperscaler that works better. Back in the day, this used to be a key use case for language translation and sentiment analysis, right? The sentiment analysis on Azure was better than AWS, especially in Spanish and Portuguese. Okay. It just was not possible elsewhere. And so I had to be multi-cloud to enable those services to just flat happen within my application. I didn't want to move the whole application, right? But it needs to be an incredibly well-strategized, well-architected decision that really comes with a financial incentive, in which case, yes, you're going to have increased egress charges, but it's to do a very, very specific thing that the company has determined is worth the money. Entirely too often, I see people doing multi-cloud because AWS had an outage once a year. Okay, that's fine. But if all you've done is extend across, you're just going to continue all of that chatter, and you probably need to do some architecture and redesign to ensure that the least amount of communication is happening from cloud to cloud, and that it's only those things that absolutely must happen, right? You don't have to extend the totality of your service mesh across all of your clouds.
Another interesting question, when we talk about multi-clouds, and maybe there's an argument that says that people want to use product across multiple clouds to avoid that lock-in that we mentioned before. Sanjeev asked, doesn't that simply move the cloud lock-in layer up into a lock-in to the products that are then running over the top? Do we need true open source multi-cloud products in order to fully avoid lock-in?
I mean, yes and no. At some point, lock-in is an academic. At some point, you can extend the definition of lock-in as far as you really like, right? I'm locked into the x86 architecture. I'm locked into a RISC architecture. Like, at some point, the goal isn't to remove all lock-in everywhere. The goal really is to mitigate the lock-in so that it allows us to have the level of agility that we need to enable best practices within our business, right? And so lock-in to Amazon or AWS, lock into Azure or AWS or GCP, that's kind of first level lock-in, right? I have very little flexibility versus if I choose Selenium, as an example, I don't make recommendations, just as an example, I have the ability to take that first level and pivot, right? You're never going to be able to fully eliminate lock-in. And even saying we're going to choose open source products and protocols, you ultimately still buy a product or you still support an open source project, which is a form of lock-in. I'm still learning how to speak their language. Yes. Do I think we need more commonality in language? Absolutely. It benefits us every time, right? If we can get 40 programming languages down to 3, like the best thing that ever happened was the adoption of Python, right? Not because it's the greatest language ever, I'm happy to have that conversation with people. I don't really have an opinion on it, but because I think it forced other language owners to really think about the ease of use of their language, the purposefulness of their language, the extensibility of their language in a really positive way. And I think the shakeout that occurred from that kind of left us in a position of the best of breed. And while Python doesn't do everything, I think it did that very well. And so I think we do need more kind of open standards that are easy to adapt, easy to adopt, easy to license, easy to use, that give us a little bit more there, but ultimately it has its own problems. And if you've ever worked in an open source, like for those who are wondering, if you've ever contributed to an open source foundation project, like a big project, especially a standards body, it tends to get frustrating, and you tend to want to just go develop your own thing and get it done. Sorry. I was in one, and let's see, what did they say? They said they couldn't. Oh, it's a standards body for security, and what they're saying is the existing frameworks aren't really complete, and they're not fast enough, and blah blah blah. And they got stuck just on the definition of a breach.
Right. Yes.
Like, if you've been going around months and months on the definition of a breach, there's no point in you even continuing.
I'm gonna counter a little bit with the, because Cilium is part of the CNCF, Kubernetes is part of the CNCF, and one of the things that the CNCF did very early on was to say, you know what, we are not a standards body. That is not what we're here for. We're here to be a home for projects, and should all be about. It's not all perfect, but it should all be about building.
Yeah, but I really like what CNCF has done because of that.
Yeah.
Right. Because they say, look, we're not here to develop a standard. We're here to help deliver products that are cohesive and coherent and speak to a core philosophy. And they do a really good job of that. I have yet to see a CNCF project where I'm like, ooh, I don't know. I don't know how that one got past I don't know how they got the stamp of approval. Again, they're not all perfect, and they're not all, amazing. At the same time, most of them are very, very good. And the CNCF has done a good job of giving you projects you can trust, which I like.
That's good to hear. Right. So we are pretty much at the top of the hour. There were a couple of questions that we didn't quite get to answer, but one of them was a question about what would be the easiest way for a DevOps person to familiarize with themselves and then master eBPF. I happen to just have on this slide a reference to a book that I just wrote. You can download it from isovalent.com. I will also mention that there's a lot of labs, isovalent.com/labs. Howard mentioned earlier, free learning resources. If you want to get hands-on with some introduction to eBPF, some introduction to Cilium, you'll find some really useful lab resources there as well. There are a couple of other links on that slide talking about an upcoming webinar that's going to be a technical deep dive into Cilium with my colleague Duffy Cooley, who many of you I'm sure will know. And there is another webinar coming up on May the 30th that will talk about the new developments that have gone into Cilium 1.13 and the Isovalent Enterprise release of that, of Cilium. So with that, I want to say thank you so much to Howard for spending time with us, sharing all this amazing, depth of knowledge that you have from cloud networking and beyond. It's been a really fun conversation for me. Thank you to all the audience for joining us and sending in your questions and comments. That's, I think the time's really flown by. Do carry on the conversation. Howard's just posted his LinkedIn into the chat, and we'll be sending around an email afterwards with links to follow up. So thank you again, Howard. Thanks to the audience, and hope to see you again soon.
This was great. I hope we can do it again. Thank you.